All right, I think we'll get started in a sec. All right, hi everyone, how you all doing tonight? Thumbs up, thumbs down? Seeing lots of thumbs up, that's awesome. Happy St. Paddy's Day. Thanks so much for taking a bit of your time tonight to spend with me. Now, I know, sorry for a lot of the confusion about the scheduling of the review session this time. This time we kept hearing a bunch of time conflicts. Apparently there's a psych midterm going on tonight, so we're kind of bouncing about, and then we decided that the best decision was just going to be to run two. Was anyone here yesterday night? Well, great to see you again. We're just going to be covering a bit of the same that we just covered last night, but hopefully this will help get a better grasp on what we were doing. So I think what we're going to do is we're going to cover test 2 and test 3, and if we have any extra time, we can go over some of the practice problems. But before we get started, are there any problems that you'd like to see covered tonight that we can get to first? Anything at all? That's okay. If not, feel free to raise your hand in the middle. I'll write it down, and we can cover that at the end. All right, so without further ado, let's get started. Now, has everyone had a chance to look over the two practice tests that were posted online? No? If not, that's okay. I'm sure we'll get through those tonight. And just to let you know, if you have any questions throughout the whole thing, you can raise your hand, or, we're all students here. Feel free to just shout out the answer. Yeah, we're all friends here. All right, so without further ado, let's get started. So the first question in test 2 says, well, it gives us that the Fibonacci sequence is defined recursively. So it gives us the first term, f of 1 is equal to 1. It also gives us that the second term, f of 2 is equal to 1 as well. And it basically asks us to create a list called f-list, which is going to be containing the first 50 Fibonacci numbers. Before we get started, does everyone get the concept of how we're defining our Fibonacci sequence recursively? So we're going to be defining each term in terms of the other two terms. So we've given term 1 is 1, term 2 is 2. We can find that term 3 is going to be the sum of terms 1 and 2, which would be 2. And then the next term, term 4, is going to be the sum of terms 2 and terms 3. Okay, so how do you think we can start? Well, since we have to create a list, why don't we start by generating our list here. So let's just initialize a list. So whenever you have to try and return something, the first thing that we're going to want to do is initialize it. Okay, and we're also given the fact that our first term and our second term are both going to be equal to 1. So actually, when we initialize this list, we can actually start by putting the elements 1, 1 in our list. Okay, so we've initialized our list 1, 1, and we want to try and continue adding elements to this 1, 1 list. Okay, well, I want to make sure I'm adding enough elements so that we have exactly 50 elements on a list. So is there any type of way where I can repeatedly add something until I've hit some sort of condition that tells us to stop? Yes, Hannah. A for loop, perfect. We can use a for loop. We can also use a while loop here. I think what might make a little bit more sense is to use a while loop in this case. And the reason why is because we've already initialized using the first two numbers. So if we were to use a for loop, we wouldn't be using a for loop 50 times, we would be using it 48 times. So because of that, it might just make a little bit more sense to just do a while loop, but a for loop works too. Either way, your choice of loop, we're going to say while the length of our f list is less than 50. And the reason why we're doing this is because, okay, if the length of our list is less than 50, we have a problem. Because we want it to be 51. So if it's less than 50, we want to keep adding to it, adding to it, adding to it, adding to it, until we've gotten to 50, and then we're going to stop. And once it gets to 50, we're going to break out of the loop. Now let's find out what we want to add to this list. So the way we add to the list, also feel free to just shout out any mistakes that I do if I make a mistake here. Because coding on paper is really hard. You end up making a lot of little typos here. So let's say I want to add an element to this list. And the element that I want to add to this list is going to be the sum of the previous two elements. Okay? So I'm going to want to add, now what's actually pretty interesting is we can index the last two elements of the list. So I'm just going to create like this temporary list to show where we're at right now. So let's say we want to generate the third element I want to index the previous element, so the -1 element here. Here, I'll write this in red. The -1 element and the -2 element. So we're going to add flist at -1 plus flist at -2. So far what we're going to be doing is we're going to be adding to our flist at the index at -1, which is going to be 1, and the index at -2, which is also going to be 1. And that's going to give us our third term. And if we keep doing this repeatedly over and over and over again, every time our list is less than 50 in length, we're going to add the next term. Less than 50, we're going to add the next term. Once it gets to 50, we're going to stop, and we're going to be done. And we'll have our list. So once we break out of this while loop, we can just print the list. And we're done. Okay, so let's everyone a test. We just finished our first question. Is everyone happy with what we just did? Any mistakes in our code? Yeah?
I think it's supposed to be a pen.
You're right, yes. So sometimes these methods can get a little bit confusing. You might recognize .add from our sets, which I'm sure we'll get to a little bit later. But remember that for lists, we're going to be using the method .append. So it's just these small errors that we want to keep those half points in all of our tests. Is everyone happy with this one? Any questions? I'll give you a moment to jot that one down. All right, is everyone ready to move on? I think the microphone's a little loud, so I'm just going to turn it down a little bit. All right, let's move on. Okay, so part B says, assume we've completed part A and have the list of the first 50 Fibonacci numbers. Wow, that's fortuitous. Because the reason that we're using it is because it asks us to create a new list, n digits, defined by where every element in n digits is the number of digits in the element in flist. Now, I know that might sound a little bit confusing when we say it out loud, so why don't we try an example here. So our flist at the very end is going to be made up of 1, 1. Actually, let's just shout out those digits of the Fibonacci sequence together. So we're going to have 1, 1, 2, 3. Hold on one sec. 2, 3, 5, 8, 13, 21. I think that's a good place to stop. Okay, now we're going to want to generate a new list called n digits. So notice our first element here, 1, has 1 digit. So in n digits, it's going to be 1. It's going to be 1. This is 1 digit, 1 digit, 1 digit, 1 digit. How many digits does 13 have? 2. Awesome. 2, and it's going to keep going. Okay, so notice that every time we're generating this n digits thing, what did we just do? We looked at the length of the element in the first one up here. We're looking at the length of this flist element. We're looking at the length is 2. So let's try and I wonder if we can find some method that can help tell us the length. Okay, so I'm going to just move this rough work over here. I know on paper you might not be able to work this magic. That's okay. So here, let's start generating our code here. Again, whenever we're trying to return some list, let's start by initializing it. So we're going to say n digits is equal to some empty list. And because we want to base every element in n digits based on our flist, why don't we try looping through flist, right? Iterating through. So we're going to use a for loop here. So we're going to say for I in range. And remember, let me know if there's any errors in my code. For I in range flist. Okay, so now we're looping through the digits of flist. What we're going to be doing is let's check every index in flist and find the length. So we're going to say we have a length which is going to be equal to flist. Oh, sorry. It's going to be equal to the len of flist at I. So this is going to give us the length of the ith term in flist. So when the ith term is, let's say it's 3, then it's going to give us the length of 3, which is going to spit back 1. So now all we have to do is let's append length to our list n digits. So we can just go n digits dot append our length. So this is going to slowly iterate through and build up our list. Okay. Any errors in this one, in this code? Can I go for it? The range of f list. Okay, that's our first error. So you're right. When we're looping through a range, remember the range has to be a range of integers. But f list is not an integer. F list is a list. So we have to actually make sure we're looping through the len of f list. Okay, so that's our first error. So we have another error here. This one's a little bit more subtle. Give you a couple seconds to think about that one. Oh, yes, right over here.
What if you read a 0 length of f list?
The sorry?
Would it be for range, would it be 0, comma, length of f list?
Oh, yes, you could do that. So you're right. We can add a 0 there. What's interesting actually about Python is if you don't include the starting value, it actually still runs properly. It just assumes 0 if you don't include a starting value. But you're absolutely right. You can add a 0. So it's going from 0 to len of f list. Is that it? Is there anything else? Jack?
You're trying to take the length of an integer?
Yes, thank you, Jackie. So right here, notice, we're taking f list at I. Now, f list at I is these guys. We're going to have 1, 1, 2. Notice those are all integers. So then what's going to happen is we're going to take the len of an integer. Well, does the len function work on an integer? No. For the len function, we actually need the argument to be a string. So the easy way to solve that is we can just convert our f list into a string. So we can just convert this like this. We're just going to write string of f list at I. And with that, if we wanted, we could print the list n digits, and then we're done. Does anyone have any questions with this one? Everyone happy with this one? See some people still writing. I'll give you a couple seconds to write that down. So a lot of stuff about these tests, we want to try and make sure to save those half marks again. So just make sure we're going to convert this to a string. We can't use that len operator on an integer. All right, I'm going to move on. All right, question 2. We got to look at the following code. So I'm going to give you a little while to kind of take that in. And part A asks, what will Python print the first time through the loop? Let's take a look at this code right here. We're importing the NumPy module library. We're giving it a little nickname here. Then we've got two functions, f at x and I wonder what that is, fp. Maybe we can use our calculus knowledge there. It's also a good reminder of good variable and function naming. Okay, and once we have those functions, we're going to have some tolerance. We're going to have some x value, and well, maybe you learned about this method in class. I think some people were asking about Newton's method. So then what we're doing is, while we're greater or equal to the tolerance, we're going to be changing our x value to be x minus f of x over f prime at x. Oh, I mean fp at x. I don't know what that means. So I wonder what this does. All right, let's take a look. I think that's enough time here. All right, so what is it going to print the first time through the loop? Well, why don't we try and digest what it's actually doing by writing some numbers down. So we know x is equal to 1. I'm just going to write that here. We also know that we have f of x is going to be equal to 2x squared minus 9x plus 4. And you know what? Since x is equal to 1, we see this f of x right here. Why don't we try calculating f at 1? So f at 1 is going to be 2 times 1 squared minus 9 times 1 plus 4. So that means f at 1 is equal to negative 3. Okay, and let's do the same thing with f prime at x. Or fp at x, sorry. fp at x is equal to 4x minus 9. That means fp at 1 is going to be 4 minus 9, which is equal to negative 5. All right, so now that we know those values of f of x, let's check out this while loop here. So the while loop says, okay, well, our numpy dot the absolute value of our f of x value. Remember, f of x is negative 3. Well, the absolute value of negative 3 is bigger than our tolerance. Remember what our tolerance is right up there? It's 0.0001. So, is the absolute value of negative 3 bigger than that tolerance? Yes, it is. So, we're going to go inside that while loop. We're going to set our new x value. We're going to set our new x value equal to, our old x value is 1. We're going to subtract f prime at x, which is negative 3, over our f prime value at 1, which is negative 5. So 1 minus 3 over 5, remember 3 over 5 is 0.6. So 1 minus 0.6 is going to give us 0.4. It's equal to 0.4. And then what's going to happen is we're just going to print our x, so 0.4 is going to be printed to the screen. Awesome. Everyone happy with that one? Did I make any mistakes? Make sure to keep an eye out if I make any mistakes on this one, all right? I don't think we made any mistakes in this one, though. So why don't we move on to part B? So part B asks, what does the output in line 14 represent in the context of the task this code is trying to accomplish? I'm going to go back up. We're going to be looking at the output in line 14. Now, I mentioned that this code is going to try and execute Newton's method. You know, I took this course a long time ago. I forgot what Newton's method is. So, I don't know, I'm going to need someone to help me. Can someone remind me what Newton's method does? It's Newton's method.
Looking for solutions.
Looking for solutions, yes. So in case everyone didn't hear that, what Newton's method is going to be doing is going to be finding some approximation to the x-intercepts of a function. And it's a great way to find these x-intercepts because it's a way that it's something that computers can execute very quickly. So what's going to happen is this is going to actually, because in our while loop, we're waiting until the absolute value of f of x is less than our tolerance. We're waiting until we actually find an approximation that is good enough. So if we find an approximation that's good enough, that's when we're going to break out. So this is going to give us an x-intercept. And specifically, it's going to give the first approximation within our tolerance. Does that make sense to everyone? Give me a couple seconds to write that one down. So it's good to try to remember all of these methods that we covered in class that may or may not show up on the test. They might not tell you what it is, but you got to keep an eye out for those. What are the other methods you guys learned? Do you have bisection? There's a third one.
We did bisection, the IVT.
Oh, IVT.
Grid method?
The grid method. Okay, that one's fun. All right, everyone happy if we move on? Okay, question 3 says, okay, in this question, we're going to represent a polynomial of degree n as a list of its coefficients. Okay, so all those a values, a0, a1, a2. Notice a list very nicely lines up with that because the first index of a list is 0. Hey Forrest, thanks for joining us. Okay, so it gives us an example. For instance, our polynomial p at x is going to be represented by 6 minus 5x plus x cubed. Okay, perfect. And it asks us to write a function, multiply at p, which will take the polynomial p and multiply it by x plus 1. How are we going to do this one? Look at how nice they're being as well. They defined the function for us. We don't have to do that ourselves. Well, you know, this is a little bit of a complicated question, so why don't we try and compute this multiplication ourselves? Okay, so let's. Why don't we use the example that they gave us? So they gave us 6 minus 5x plus x cubed, and we're going to multiply it by 1 plus x. Okay, how are we going to do this multiplication? Well, we're going to want to FOIL out these brackets. And I'm going to write them in 2 different colors because there's a little pattern that would be kind of important to remember. So here we're going to get 1 times 6 minus 1 times 5x plus 1 times x cubed. Notice this is going to remain the exact same as the list we started with. Okay, and we're also going to need to multiply x by each of those terms. So we're going to get plus 6x minus 5x squared plus x to the 4. Okay, notice this one is exactly the same as well, except we've added an x to each of these terms here. Now, in terms of a list, when we add an x onto each of these terms, what is that going to do to the indexes of each list? The indices. Well, if we remember our list, we're starting with a0 is a power of 0, a1 is a power of 1, a2 is a power of 2. What's going to happen when we multiply everything by x? Everything is getting multiplied by x. Powers change, it's going to multiply by x. We're shifting the entire list by an index of 1. Okay, so let's try and do this in code here. So why don't we do this? We've got this blue section here, which is multiplying by a constant, and we've got this red section here, which is multiplying by x. So why don't we do this? Let's create a list called CList, which is going to represent our constant. And let's just make a copy of our list P, because P already is our constant list. It's the list that we're given, multiplied by just 1. Now, whenever we're copying a list, this is another little quirk in Python. It's just a good way to, a good practice to try and slice the entire list instead of copying, or instead of just assigning it to P. This is just because of some other reasons, a little bit deeper within the code of Python. But just make sure that whenever we're trying to copy a list, make sure to slice it. Is everyone familiar with slicing? So here we're just taking an entire copy of P. And now we're going to do the same thing with our x list. We're going to want to do our x list. Here, I'm going to write this right here. So we're going to take a slice of P. But we also want to shift everything by 1. That's the shift we were talking about earlier. So when we shift it by 1, actually notice we're going to have a 0 constant term. Like notice we have no constant term in our red polynomial. So what we're going to do is we're going to want a0 to be equal to 0. And we can just add those 2 lists. If you like, you can also use the extend method. So we could have done 0.extend. P. Everyone know what the .extend method does? Have you done that in class? It's just like the append method, but for multiple elements. Okay, and now that we've got our C list and our X list, what we're going to want to do is we're going to try and add those 2 lists together. Oh, sorry. One of those 2 lists is obviously going to be bigger than the other. Just shout it out. Which one's bigger? One's going to have 1 extra element in it. X list, exactly. X list is going to have that extra 0. So what we're going to do is we want to make sure that we're not, if we try and loop through both of these, we don't want to reach the end where one of them is going to loop further than the other. So why don't we do this? Let's loop through C list. And we'll loop by our index. So let's loop for I in range. We're going to grab the length of C list. Okay, and then what we're going to do is we're going to add the terms to XList. So our current value at XList, we're going to add the current value at CList. Plus equals our value at CList at I. So every single time, what we're going to do now is, this is the equivalent of saying, okay, now we want to add our -5 plus our 6. That's going to turn into 1x. And it looks like none of those other ones will add together. We're adding each of these terms. And we're adding them to the list XList. So XList is actually going to end up turning into the list we're going to return. But now it looks like we're done, so we can just return XList. Is everyone happy with this one? Any questions? Did I make any mistakes? I forget to add a bracket or something. All right, I see some pens moving, so I'll give you a couple more seconds to write that one down.
Wait, isn't CList shorter than XList though?
Yes, you're right. CList is shorter than XList.
So doesn't that mean that if you're trying to index,
Well, so let's take a look. So CList is shorter than XList, you're right. So let's look at what our CList and XList would be after this step. So I'm going to do it right here. So our CList, again, is going to be made up of this blue. So our CList is going to be equal to 6, -5, 0, 1. Does everyone get how we got that there from those coefficients? Okay, so our CList is going to be that, and our XList, which is coming from right here, that's going to be made up of 0, 6, -5, 0, 1. So no, it's just shifted down by 1. Okay, so now what I'm suggesting is we're going to iterate through CList. And every time we iterate through CList, so this first element, we're going to grab the XList element. Same thing here. We're going to grab this element matching, we're going to grab this one, we're going to grab this one and add it. So we're adding CList to XList. That's okay. But, so notice there's the 0, 1, 2, 3, 4 index here. What if I tried to add the 4th index to the 4th index of CList? What happens if I try, yeah,
out of range?
out of range, yes, exactly. So if I try and add XList to CList at position 4, we won't even be allowed to do that. Python's going to crash because it's going to say, hey, we don't have a 4th element or a 4th index. We don't have the 5th element. So that's why we're going to try and add CList to XList, and then we're going to return our XList. Does that make any sense? Awesome. We good to move on? Perfect. All right. Question 4. Taylor's writing a function called echo of S. That's supposed to echo the characters in a string S an increasing number of times the following way. So the first character isn't repeated, the second character is repeated once, the third character is repeated twice, so on and so forth. So in particular, if we start with the word cloud, then the output is a cloud. D with 5 Ds. Okay, and then Taylor wrote an attempt of code here. So what do we think Taylor's code is going to print out? I'll give you a couple seconds to think about that one. Everyone want to write down, let's just write down like what you think it's going to print out. We can try and compare with the end. All right, why don't we try it here? Okay, so we're saying that S is going to be equal to cloud right here. So we're going to have echo of cloud in here. Okay, so for I in range of 0 and the length of S. Now first off, tell me, what's the length of S? Is it 4? So we have 0, 1, 2, 3, 4. Is it 4? Who thinks 4? No, why not?
The length is 5.
Yes, the length is 5. So the length is actually always 1 more than the final index. So length of S is 5. So we go for I in range of 5. We're going to add to S the index times, I guess that many times is going to appear. So what's going to happen is we're going to start with cloud. And I'm going to write it out again because this is going to be represented by our indices here. Okay, so now we're going to add to cloud C at 0 times 0. So what's any letter times 0? Not 0, it's just the empty string. So a string, when you multiply a string by 0, it's just the empty string. So we're going to add nothing to cloud. Okay, we're going to iterate through again. So we're on number 1 now. So we're going to get the index at 1. The index at 1 times 1. So we're going to have 1 copy of L, and we're going to add it. Okay, so this already isn't looking like what it's supposed to. But that's okay. We're going to keep going. So now we have O. We're going to add 2 copies of O to our string cloud. So what happens if we add 2 copies of O here? Doesn't look right. Okay. Same thing's going to happen with U. So here we're going to add 3 copies of U. And then we're going to add 4 copies of D. So this is our output. Now that doesn't look like the right output that we're trying to get to here. Maybe there's some small errors in Taylor's code, but let's try and fix it together, shall we? All right, so it says fix Taylor's code. We're going to write a function called echo, so it produces the desired output. And we're going to write this code from scratch. So just as a reminder, we're going to take the word cloud, and that's going to turn into C, L, L, O, 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 U, 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 D, 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 D. Okay, well the first thing that I'd suggest is, or I guess the first issue that we have here is we're trying to add letters to the existing string. But we don't want the existing string to be there. We don't want cloud to already be there. So why don't we try this? Let's initialize a new string. So remember, whenever we're going to want to return something, let's always start by initializing it. Let's just call it string. And we'll initialize with the empty string. All right, so now why don't we try adding letters to it? So we want 1 copy of C. Actually, so why don't we start by iterating through cloud. So for I in range, the len of our word. Remember, our input word is S. So we're going to say for I in range, the len of S. Okay, now we're going to want to add something to our variable string. So we're going to want to concatenate another string. Now what are we going to want to add to it? Well, we're going to start, let's say we're on the 0th index. If we're on the 0th index, how many copies of C do we want to add? 1. And if we're on the 2nd index, which is L, or sorry, the 1st index, which is L, how many copies do we want? 2. If we're on the 2nd index, we want 3 copies. If we're on the 3rd index, we want 4 copies. Notice we're always going to want I plus 1 copies, or index plus 1 copies. So why don't we do this? Let's grab the letter that we want to add, which is S at I, and then let's multiply it. Let's multiply it by, what am I going to put in that bracket? I plus 1, exactly, because we want I plus 1 copies. Perfect, we've completed our function. All right, so are we done this question? Everyone happy with that one? Yeah. Return, yes. So whenever we define a function, we're going to want to make sure there's a return statement so that the output of our code can actually come back from the function into wherever the function is called. So we're just going to return string. Awesome. Give you a couple more seconds to write that one down. Everyone comfortable with that one? All right. Question 5. All right, so an n by n matrix can be represented as a list of n elements. Each element is a list representing one row of the matrix. All right, and it asks us, it gives us this mystery function here. We have to try and figure out what that mystery function is going to print. Do we have any guesses? Give you a couple seconds, don't take a look at that one. Any guesses what the mystery function is going to print? Is it too small, by the way? Is that why you're taking the pictures? I can make it bigger.
It's fine.
It's fine? Yeah.
The n by n zero matrix.
The n by n zero matrix. That's a great guess. Anyone else? Who thinks the n by n zero matrix? Why don't we take a look? All right, so it looks like we're going to want to try and print n copies of 0. All right, so it's going to be a list of n zeros. And we want to also do this. We're going to say for k in range 0 to n. So that's telling us, okay, n times, we're going to want to print a list of n zeros. N times 1, a list of n zeros. Okay. And it also gives us that n is 4. So we're going to want 4 copies of a list containing 4 zeros. Well, let's write that down. So we're going to have a list, and we want 4 copies of 0 inside of each list, and we want 4 of those. Is everyone happy so far with how we got to this? 4 copies of lists with 4 zeros in each list. Okay, and if we were to arrange this list in a matrix, 4 rows, what did you say it was earlier?
N by n zero matrix.
The n by n zero matrix. And that's exactly what it is. All right, perfect. And now, question B says, okay, using the function mystery at n from A, we want to write some code. Sorry, you can't see that. Write some code that creates the n by n identity matrix. Are we all comfortable with what an identity matrix is? We all take 1B. Suffer through it. All right, so Hannah's shaking her head. So we want the identity matrix here. So the identity matrix is going to be filled with all 1s along the diagonal and 0s everywhere else. Actually, let me make the 4x4 identity matrix since we happen to have it. Now I'd like to do a little experiment here. Notice that we've got 4 1s here along this diagonal. Can we take a look at the indices of each of these? Let's look at the number of rows and the number of columns of the positions of each one. So notice the first one here, that's in the 0th column. It's also in the 0th row. Okay, this next one, the first column and the first row. The next one is in the 2nd column and the 2nd row, and then the next one is in the 3rd column and the 3rd row. Well, you know what? It seems that those indices are the same. So notice what we can do is maybe let's generate a matrix that's already the 0 matrix. So let's use our fancy mystery of n function. So now that we've got the 0 matrix, let's loop through that matrix and try and find a way to modify every ith entry to be 1. Okay, so we're going to loop through. So we're going to say for I in range of n, we're going to edit the matrix at the ith entry to be equal to 1. So when we're at the 0th entry, we're going to get to 1. When we're at the 1th entry, when we're at the 2th entry, and the 3 entry. Does that make sense to everyone? Awesome. So I'm just turning on Do Not Disturb. There you go. All right. Give you a second to write that one down. So now we've reached the end of test number 2. Yeah, anyone have any questions about that one? If not, we're going to move on to test number 3. All right, so this one has a lot more multiple choice here. So I think what we're going to do is let's take some votes on what we think these correct answers are supposed to be. That sound like fun? All right, so here's the first one. It asks, what's the output of the given code? Gives us a little dictionary here, and it tells us to print the results of S at 3. Ooh, okay. So we know in dictionaries there are keys and there are values. So what's 3? Is 3 a key or a value? 3 is a key. Okay, so what happens when we print S at 3? What do we think? A? B? C? D? Lots of D's. Okay, awesome. That's pretty easy. All right, let's try number 2. We're given S, and we also now want to print S at 3. Okay, so what do we think it's going to print out here? 5, going to print 6. Or is it going to print an error? Okay, well, let me ask you, what's S? Is S still a dictionary, like our last question? No. S is a set. So what happens if we try and print S at 3? If we index a set? Hannah shaking her head. Get an error. All right, now let's try number 3. Let's work through 3 because 3 is a really, really important one. Actually, 3 was, I got this one wrong when I took this test. And it's one that really throws you for a loop. So I'd really like you to try and find out, I see some pointing up there, I think you guys have caught on. I want you to try and figure out what this code is going to output. So try and run through it. We've got our function, it's calling the function. We're going to print out. What are we thinking? Whenever someone's feeling confident they got an answer, no need to raise your hand, just shout out the answer. Anyone else? In the back? Just show me with your hands. You guys are quick with this one. Anyone on this side? Hannah?
Still dealing with it.
All right, so let's have our vote now. All right, so what do we think? We think A? What about B? C? Or D? What's D? D's 42? Why do I think it's 42? Why do I think it's 42? Okay, well, let's take a look. For I in range, we've got 0 to max steps. So for I in range 3 here, remember max steps is 3, and x is 2. We're going to add 2 to the power of 2i plus 1. So what's going to happen is, when I is 0, 2i plus 1 is 1. So we're going to have 2 to the 1 plus 2 to the 3 plus 2 to the 5. And we know if we add this sum together, this is going to give us 42. So is 42 the correct answer here? Did I make a mistake? I think Forrest, you want to share.
Well, there's this return statement nested inside the code.
The return statement is nested inside the for loop. So just remember this very easy little indentation right here. Notice that the return loop is actually going to return the result on the very first iteration of the loop. So all we're going to get is 2 to the 1, which is 2. Way out there in the back, you guys got it as well. So half a mark bonus. All right, let's go to number 4 here. So number 4 gives us a set. Oh, yes, ma'am.
Just a question about it. When a function returns something, does it always end after once?
So a function call will always terminate once it hits the return statement. So return statement will always stop it. So a function can't return multiple times. It can return multiple outputs, but that requires like separate arguments with a comma and stuff like that. So with this return statement, no, it will only ever return one thing, which is 2. not 42. I got checked by that as well, so keep an eye out for those indentations. All right, question 4. A is the set Monday, B is the set Wednesday, S is the set with nothing in it. All right, I'm going to try and work through this one. Oh, yes?
I'm wondering if I put a return sum in a correct place, so what will be the output? I mean, because the last question, because there's a max steps equal to 4, but there's also a 2, comma 3 in the bottom line.
Yes. So when you put this max steps here, right here, when you set a variable equal to a number inside the function, what that does is it sets the default. So the default is 4. So if I wanted to, if I called h and I wrote h of 2, I didn't put a second argument, it'll just assume that I meant 4. But since I put 2, 3 here, I'm changing it to 3. So what's inside the function call right here will always take priority over a default. So that was your first question. And then your second question was if we put the indentation in the right place, right? So if it was in the right place, then you're right. It would print out 42. The only reason that it prints out 2 is because it terminates too soon. It terminates before we've had a chance to add up all the terms. Does that make sense?
Yep.
Does that answer your question?
Yep.
Awesome. Great question, by the way. All right, let's go back to question 4. So I'd like to work through this one. Just shout out if you think I've made any errors. All right, so A is the set Monday. So A is going to end up being the set containing a single string, Monday. We have B is going to be the single set containing Wednesday. And S is going to be an empty set. How does that look? Looks pretty reasonable. Has given me a little nod of approval. Hand up.
Aren't the sets iterable, so it separates like into the individual characters?
Yes, you're right. So a set, when you say we're going to define a set based on a string, it actually breaks apart that set, or breaks apart that string, so that every single character in the string gets its own place. So this is actually wrong. This won't print out a set containing Monday or Wednesday. A is going to be the set containing M, then O, then N, then D, then A, then Y. So this is actually a really interesting quirk of Python here. So make sure, just remember, whenever you input a string into a set, it's going to break them up character-wise. Okay, and the same thing is going to happen for Wednesday. And I'm not going to write out the whole thing, just in the interest of time, but I'm just going to go up to N. Okay, so from here, what's going to happen is, okay, we're going to loop through, we're going to iterate through the elements of A. And if the element is not in B, we're going to add it to S. Okay, so let's start. Is M in our set B? Do we see the letter M in the word Wednesday? No, we don't. So we're going to add it to our S. Do we see the letter O in Wednesday? No. Okay, do we see an N in Wednesday? Yeah, we see an N in Wednesday. We also see actually every other letter, D-A-Y, in Wednesday. So every day ends in day. So actually our set is only going to be M-O. So C is going to be the right answer for that one. Does that one make sense? So it's just about remembering that slight little quirk of Python. All right. Question 5. Here we've got the dictionary. It's going to give us that milk. It's going to be $60. Fruit, 3,600. Chocolate, 1. Bread, 54. They should name this list all the stuff that I want to be eating right now. Okay, and we're going to want to have some sort of function, m, s, and t. And we're going to return m times d at t divided by d at s. I'd like you to take a couple seconds on this one. We're going to vote on this one in a sec, okay? So give it a try. Or not, a couple seconds. All right, what are we thinking? Do we think it's going to print A? Option A, 10.8. Got some hand. What about option B? 0.9. Option C, 13.3. Okay, and option D, 1.11. Okay, option C. Who voted for option C? Do you want to share why? Who now wants to switch to option C? Anna? No.
I think it's A.
You think it's A? Why do you think it's A?
I mean, that's just what my calculator put out.
All right. Well, here's the interesting trick in this question, right? Notice that they swapped the order. We have S and T here, and we've got T and S there. So just anyone who picked C, remember, they actually flipped the order on you. So let's just make sure. We're going to have D at bread. That sounds a little weird. You always think you're having some index of to be a number. But anyways, D at bread, that's going to give us 54. And we're going to have D at milk, which is going to give us 60. So all we're going to be returning is m, which is 12, times d at t, which is milk, which is bread, which is 54, divided by 60. And that's going to give us 10.8. All right. Move it along. We got question 6 here. What do we think about question 6? We've got a dictionary. It's like the months of the year.
Could you scroll back to question 5?
Sure. How's that? Alright, is that good? Anyone else want question 5 up for a bit longer? Alright, question 6. We've got our dictionary. It's asking us what's going to print if we have March in D. Because remember the in command, remember that? Checks for the keys in the dictionary. So currently, is March a key? March is not a key, so it's probably not going to print true. I'm going to cross out true here. Let's do a little process of elimination. Words are hard. Okay, what do we think? What do we think? Is there going to be an error? There's going to be an error, right? March isn't even in our dictionary. And I gave you a little face. What do you think? No error? Why not? I think there's going to be an error. I think I want to answer A here. You're right. There's no error. Actually, remember, this March in D is going to print a true false. If we remember from back in our strings days. So it's not going to print an error, and it's also not going to print 3. Remember, a dictionary will take a key and print a value. It can't take a value and print a key. It's not going to be 3 either, so our answer is going to be false. All right, let's take a look at question 7 here. Question 7 says the code in the cell is supposed to count the frequency of each digit, 0 to 9, in the string called pi. Which command should be inserted in line 4 to obtain the output that we desire? All right, so let's try and fill the code in this gap. First thing, let's notice that our iterator variable is called ch, or like ch. All right, so have we ever been told, are we ever going to try and change the iterator variable manually? I don't know, I'm not sure. I'm asking you guys. I legitimately don't know the answer to this one, so let's try and figure it out together. What do we think? Do we think it's A? We got some A's, yeah? What about B? No B's. What about C? Any C's? Any D's? So you're right, it is A. But let's take a look at why. So we're going to take a look at each of B and C and D and show why it's not correct. So again, what I was talking about earlier, you never want to change the iterator variable. The for loop's going to do it for you. Right? We don't need to change it. If we try and change it, I don't think anything will happen. I just think it won't change. The for loop doesn't like that. But we can cross that answer out. Okay, now L, what's L? L is a list. So if we try and do a list with the round brackets here, that's not how we index a list. When we index a list, it's got to be square brackets. So try and put this in your code. That's not going to work. Remember, the round brackets are only for function calls. Or for tuples, but I don't know if we're doing tuples. We've got B, which is the int of ch plus equals 1. Well, in a for loop, well, actually, no, ch will, or actually, yes, ch will already be an int because every element in, oh no, sorry, that's a string, you're right. Well, we're trying to change the iterator variable again. All we're doing is we're changing it as an int instead of as a string. We never want to try and change that iterator variable, so A is our answer. Everyone happy with that one?
Can you just explain one more time why it's A?
So the reason it's A here is because we're taking the int of our character value, right? So let's say we want to count the number of ones. So we're going to start, I'm gonna lower this. We're going to start by looking through pi here. We're going to start with this first element, 1. So how am I going to count the number of ones? Well, I want to try and count it by storing it in a list where the index 1 will store the number of times 1 occurs. So we're going to say, okay, let's index our list L at 1. Right? We need to index at an integer. So we're going to index at 1, and we're going to add 1. We're going to add 1 to the counter. Let's say our next digit was 4. Then we're going to index our list at 4 and add 1 to the counter. Or if our next digit is 5, we're going to index at 5. We're going to add 1 to the counter. If our index, we find 1 again, we're going to index at 1 and add 1 to the counter. So every time we get a digit, we're going to index at that digit and add 1 to the counter. And what we're going to get at the very end is a list. And that list is going to store the number of times each number occurs. And it's going to store it at that number's index. Does that make sense? I know that's a little bit tricky. Do you want me to go over that again? All right, awesome. Thanks for your question. Good question, by the way. All right, so question 8. This is the last multiple choice question, I believe. It says we're going to look at the code. Which command should be inserted in line 5 to obtain? I'll put this down below. Again, we got lots of delicious fruit here. Okay, let's try and take a look at this output here. All right. What are we going to do? What do you guys think? Let's vote. I think it's A. Any votes for B? C? Lots of hands for C. What about D? All right, why do we think it's C? Any of the C voters? All right, well, let's try and take a look. Let's test out A first. I think, let's try and test out A. So we're going to say that our cow food list at I. Now remember, our cal food is going to be a dictionary. So we're going to take our cal food at I. It's going to be equal food at I. First thing to note here is that we don't have a single pair of brackets here. We've got two. Now, I don't know about you guys. I don't think I've ever seen that when coding in Python. So it's already triggering those iffy, like, not sure things. Because we haven't seen it, I think it's probably not going to be right. So why don't we get rid of that one for now. Okay, number B, calories per 100 grams. We're going to index that at I. We're going to have cal food here. This is a little bit iffy too. What's this going to do? We put square brackets at I. What it's doing is we're going to be setting it as a list. Do we want our cal food at a certain index to be a list? Do we want to put a list inside a dictionary? I mean, maybe. But I mean, that's not the output that it's giving here. So let's assume that for now, B is not right either. Okay, let's take a look at C. So what C is doing is we're going to take the calories per 100 grams at I. So here it's going to grab that 52. Then it's also going to grab our cal food here. So our cal food, which is 52. And what it's going to do is it's going to set, in our dictionary cal food, it's going to set that value for I to our food at I here. So it's going to make some dictionary, it's going to build up some dictionaries such that, okay, let's say we're iterating through. We take the food that has 52 calories, and it's going to set it to apple. We're going to set its value to apple. We're going to take the key 89, and we're going to set its value to banana. We're going to take the key of the number of calories it is, and set it to the name of the food. Wow. That looks a lot like the output we're getting right here. So maybe it's C. Kind of looks like C to our first glance. So let's take a look. Let's just assume it's C for now. Let's try and find out why it's not D. Okay, we've got cal food at food of I. So what's going to happen is we're going to take our food list at our index. We're going to set it equal to the calories per 100 grams at I. We're going to set that equal to the food at I. Going back to those other suspicions we're having. Look, we've got a couple sets of, we've got an unmatched bracket here. That's no good. What's going to happen if we put this in? Got an extra bracket on one side, but not on the other. I don't know about you guys. I think this is going to crash. So, I mean, if it crashes, it can't be the right output. So, the answer we have to go with is C. Everyone happy with that one? All right. Let's move on to 9 and 10. By the way, I see a lot of people hanging out right now. That's okay. But if you wait till question 10, I'm sure it'll be worth your while. You might recognize it. But we'll get to that in a second. All right, question 9, it says, given are two lists, L1 and L2 of the same length, which contain real numbers or integers. And it says, without using the max and min commands, we're going to write code to create lists Lmax and Lmin, where Lmax at I is going to be the smaller of the two, and Lmin at I, Lmax at I is going to be the bigger of the two, and Lmin at I is going to be the smaller of the two. How are we going to generate these? All right, well, anytime we're going to have to generate stuff, why don't we start by initializing. So we're going to set, let's create this new list. We're going to have Lmax equal to some empty list. We're going to have Lmin also equal to some empty list. Okay, now why don't we try and do this? Let's iterate through our L1 and our L2 lists, because we're going to want to try and compare the elements at each position. Also notice they're the same length. We can just assume they're the same length. I believe they said we can assume, yeah, of the same length. So, because they're the same length, let's just loop through the length of the first one. So for I in range, the len of L1. Now what we're going to do is let's compare the current number of one list to the current number of the other list. And the reason why is because we're going to want to add the bigger one to Lmax, and we're going to add the smaller one to Lmin. So let's compare. We can make a comparison easily with an if statement. So we're going to say if our L1 at I is bigger or equal to our L2 at I. Who said no? Was that you, Ford? No? Did someone say no about this? Let me know if I made any mistakes in my code, by the way. Jackie?
What?
Is there an error here?
That's not code.
That's not code. What's not code?
Greater than or equal to.
The greater than or equal to. Exactly. We can't write greater than or equal to in our code, right? So just remember, we're going to want to include a greater than or equal to like this. Thanks for paying attention. All right. Now, we've got our greater than or equal to here. Now, if the reason why we can set it equal to is because if both elements are equal, it doesn't matter which one goes in which list. Okay, so if our L1 at I is going to be bigger, then it should go in the max list, shouldn't it? So we're going to append our L1 at I to our max list. And we're going to append the smaller one, so our L2 must be smaller, so we'll append L2 at I to our min list. Okay, and let's take an else. If the L1 is not bigger than L2, then that means L2 must be bigger. So L2 is going to go into the max list. So we're going to go lmax.append our L2 at I. And then the smaller one must have been L1. All right, and with that, I think the question's done. Give me a couple more seconds to write that one down. That one makes sense to everyone? Any questions? All right. Let's move on. Question 10. Given two dictionaries, D1 and D2, create a new dictionary, D3, according to the following rules. Okay, if there's an entry AB in D1 and an entry BC in D2, then we should create an entry AC in D3. Wow, that question looks awfully familiar. I can't remember where I've seen it. When's assignment 3 due? I'm just curious. When's assignment 3 due?
Friday.
This upcoming Friday? Right. So
Yeah, right.
I don't know where this question is familiar from, but you might end up seeing it again. Okay, so our goal is we want to try and generate a third dictionary, D3, based on our D1 and D2. Now, right now there's a lot of letters. A, B, C, I don't know where they're all going. So why don't we try and draw some picture that helps us? So what we're going to do is we're going to take a look at D1, D2, and D3. Okay, so D1 is going to have some key and some value. KB. Okay. Now D2, what it's saying is, okay, if our value B is in D1, is the key in D2, so if the value of D1 is the same as the key in D2, what that's saying is we want our key to be V. Okay, and let's call some other entry W. So what it's saying is, okay, if we have V pointing to V here, then let's create a new D3 with KW. Does that make sense to everyone? So how are we going to code this? All right, so let's remember, if we ever want to try and grab both the key and the value and iterate through, you can do that with a dictionary, which is really awesome. So what we can do is we can, well, let's first initialize our D3, which we want to return. And then let's write for KV in D3, or sorry, D1 dot items. No way. So doing this dot items command, we're going to be able to grab the key and the value and loop through both of those at the same time. So we'll have access to both the key and the values. So how are we going to use that? Okay, so what we can do is we can check, we can say if our value is in D2. So remember, if our value is in D2, that's going to mean that we passed the test. We've got our key, or sorry, our value of D1 right here to be a key in D2. Okay, so if we've passed the test, then what we're going to want to do is we're going to add that to D3. And it's going to be added to D3 with the key here, which is going to be set to our value of D2. So keep in mind right here, this is going to be a value. Okay, now I'm going to write this additional code in a different color because this is going to this question slightly differs from your assignment. You can get the picture. So we're going to say else. So if V is not in D2, then we're going to want to set it to no match. So this question says to set it as no match. Don't copy this orange part. It's a little bit different. And then once we've generated that D3, we are done. And with that, I think we finished both test 2 and test 3. Anyone have any questions with that one? All right, so I'd like to ask, is there anything that you guys want to continue doing? I mean, I know we've spent an hour and 15 minutes together already, and I know it's St. Patty's Day. So if you'd like to enjoy the rest of your night, feel free to go now. If you like, we can also go through some other topics as well. Do you have any preferences? Practice problems? It seems like everyone's itching to go, so why don't we call it here? You know what, thank you so much again for joining me, and hope you have a great weekend. And good luck on the test on Monday. All right, take care, everyone.